Good morning, children. Today we are going to see our 7th lesson, electricity and magnetism. So, electricity plays a huge role in our daily life. This we already know, is it not? We cannot spend our night time without our light and fan. We cannot watch movies without electricity. We cannot spend the summer without our AC. Okay, so all this is depending upon electricity. This electricity is obtained as an energy. So that energy is called as electrical energy. Okay, so electrical energy is the most useful form of energy. And it can be easily converted to other forms like light, heat, mechanical energy and chemical energy. We are going to see all that now. Okay, first we are going to refresh our laws of magnetism. In 6th standard we have already learned like poles of the magnets will repel each other, whereas unlike poles of the magnet will attract each other. Okay, so like poles, what do you mean by like poles? That means we already learned bar magnet. Okay, see, this is what we have learned in our 6th standard. This is our bar magnet. And when the poles are of different ones, that is unlike poles, when one side is north pole and the other one is the south pole, what will happen? They both get attracted. Whereas if both the ends are north poles, they will be repelling. So these are the two properties of a magnet. So that is what they have written here. The like poles of the magnets will repel, whereas unlike poles will attract each other. Now coming to the test for magnets, we can see whether the material is a magnet or not by just keeping iron, cobalt and nickel nearby. If these materials are attracted, okay, then we can say that material is a magnetic material. So attraction between a magnet and a magnetic material will help us to find which one is magnet, and we are using that for identifying a magnet. Also, repulsion is a sure test for identifying the magnet. Okay, repulsion means what? If both the poles are of same sign, that is if both are north poles or if both are south poles, then only they will be repelling. So we can say the material, okay, that means the repulsion is the sure test for identifying a magnet. Coming to electromagnetism. What do you mean by electromagnetism? We are going to combine electricity and magnetism together. Okay, that is we are going to combine two huge processes, so that becomes the word electromagnetism. Okay, that was a huge research means what? So many scientists were involved and they were discovering many things based on electricity and magnet. Okay, finally we were able to find out in 1802 our Italian scholar Gian Domenico Romanzi. Okay, he deflected a magnetic needle by electrostatic charges. Okay, then in 1820, almost 20 years later, Hans Christian Oyster observed that a compass needle will get deflected if it is nearby. Vicinity means nearby, if the electric current is there. Okay, so they were trying to establish a relationship between electricity and magnetism. So that is how this new term called electromagnetism came into picture. Okay, so what are electromagnets? Electromagnets means a magnet which is created. It is not a natural magnet, which is created when the flow of current, when there is a flow of current through a coil. There is a coil, okay, wound around a soft iron core that is called as solenoid. So the electromagnet means it's an artificial magnet. Okay, it is not a natural magnet. Okay, so magnet is created when there is a flow of current through a coil. Coil means a wound wire, okay, copper wire, and which is surrounding a soft iron core. And electromagnets are temporary magnets because whenever we switch off the electricity or whenever we switch off the flow of current, the material will lose its magnet power. Okay, so that is what they say. They lose their magnetic properties when the current supply is cut off. See, they have given an example. Take the iron nail. You know what is iron nail? Okay, take the iron nail and insulated copper wire. Okay, insulated copper wire. The copper wire would be like this. Insulated copper wire. And you should take a iron nail and you wind a wound. The wound means you have to what? Turn and turn and turn, and you have to make a design like this and attach it to the what? Battery. Okay, they are saying take the iron nail, wind it with several turns of insulated copper wire, connect the free ends to the battery, switch on and switch off. What is happening? Okay, the iron nail attracts the needle. This iron nail will attract the iron particles only when the power is there. When I switch off, it will not attract. Okay, so electromagnet means it is a temporary magnet which is controlled by the flow of current. Okay, so the strength of the electromagnet is depending upon the magnetic field. That is, the magnetic field is made with the number of turns, okay, or the magnitude of the electric current. Okay, either it is on the number of turns or the amount of current which is passed through. Okay, and the nature of the material. If it is iron or nickel or cobalt. Okay, now we are saying that we are going to create a new magnet called electromagnet. The moment magnet word comes into your mind, you should be considering where are the poles. Okay, since this is an electromagnet, we have to find, because it's an artificial magnet, we have to find the polarity. Polarity means where the poles are. Which pole is this? Is it North Pole or is it a South Pole? So, the polarity of the electromagnet will depend on the direction of the flow of current. So, which direction the current is flowing. Okay, so it is mainly dependent on that. So, we have seen that in the case of solenoid means nothing but a simple coil. Okay, the direction of the current will determine which end of the magnetic lines of force will emerge. We know, okay, the magnetic lines of force will emerge only from the poles. Okay, so the reverse direction means the electromagnet poles also is getting reversed. Okay, you don't worry about that. You should only know that, okay, we are going to use, see the solenoid. The solenoid is here. The flow of current is in this direction. If the flow of current is in this direction, that is called the North Pole. You keep your hand like this, and if your thumb is pointing up, that is the flow of current is in the upward direction. This is the North Pole. If I put it down, that means my flow of current is in the downward direction. That means my North Pole is in the down. So this means then this top will be my South Pole. That is what they are saying. Okay. Next, what are the uses of electromagnets? Electromagnets are mainly used in motors, generators, loudspeakers. Then they are used in relays. Relays like our switch gears. In every house you will be having a relay. The moment the fuse is gone, the relay also will be down. And then it is also used in the sorting the metals in the car junkyards. And it is also used in the rail transportation, all this metro trains. Okay. Next, we will see how an electric bell is working. Electric bell, our calling bell. We just press on the what? The switch, calling bell switch. What happens? We will see. The moment we switch on the bell, that is we switch on. This is the switch. So the electricity will flow from the battery. The connection is closed. So battery or the electric line. Okay. It will pass. It will go to the magnet. This is the electromagnet. We saw that the moment electricity is passed through this, what happens? This becomes electromagnetized. That is, it is a magnet. Now, that wire is connected to an iron bar. And this iron bar, okay, is connected to a hammer. Now, when I close the switch, that is when I am pressing the switch, this circuit gets closed. Closed means there is a flow of current. So, the electricity will flow in this direction. What will happen? It will magnetize this electromagnet. The moment this becomes magnet, it will attract this iron bar. Iron bar means it will be attracted by the magnet. So, the moment this gets attracted, this hammer the hammer will go and hit the gong. This is the gong. That is where the sound is coming. The shrill sound or whichever sound you want, you can get it. So, an electric bell is a device that works on an electromagnet principle. The diagram they have shown, it consists of an electromagnet. How is this electromagnet formed? With an armature made of thick iron bar fixed on a spring. So these two are the thick iron bars which are fixed on a spring. Okay, and then they are making a brake arrangement with a screw. They are making a brake arrangement with the screw S and an iron strip P. So this is a total arrangement. Okay, so when the switch is pressed, the current flows through the coil. So this moment the magnet is, this iron core will act as a magnet and pulls the iron bar on the top. So the hammer will go and strike the gong, which will give the sound. Okay, when I release the switch, what happens? The current will not pass through this. So this is losing this magnetic property. So the iron bar is released back. That is what they say. Iron strip P loses its contact with the screw. So the circuit will break and the current will stop from flowing through the coil. So electromagnet loses its magnetic power. So iron bar will go back to the spring. Okay. So this is how our electric bell is working. The breaking of the circuit will continue until the switch is pressed and the hammer will repeatedly hit the gong so that it will give the ringing sound. Okay, until you are keeping your hands off the switch, the electric bell will keep on ringing. Okay, so go through this slowly, understand the concepts and get back if you have any doubts. Okay, thank you.